Starting with the last term question, it says there are 5 statements about ice and water below. Give the letters of 2 statements that are correct. So if we take each one in turn and decide if they are true or false. So A says the molecules move faster in water than in ice. Well, we know that's true because in water, a liquid, the molecules have more energy than they do in ice, a solid. So A is correct. B says the molecules are more randomly arranged in ice than in water. We know that's not true because ice is a solid and has a much more fixed, regular arrangement of particles than in a liquid, so it can't be B. C says the molecules start moving when water becomes ice. We know that when water becomes a solid, the molecules actually stop moving because they lose energy, so it can't be C. D, the molecules are arranged more regular in ice than in water. Well, we know that's true because solids have a more regular arrangement than liquids. So the 2 statements that are correct would be A and D. And just to check, we know it can't be E because the molecules in ice have less energy than in water. Solids have less energy than the particles in a liquid. If we move on to the last month question, you were asked to complete the table. Well, we know that the proton has a relative mass of 1 and everything else is measured relative to the mass of that proton. The neutron weighs the same as a proton, so also has a relative mass of 1. And we know the electron was significantly lighter than a proton, so we had the mass of 1 over 2,000. You will see in some textbooks it could be 1 over 1840, or you could say tiny, very small, or negligible. In terms of charge, we know P protons are positive and they have a +1 charge. We know neutrons are neutral overall, so they have a charge of 0. And we know electrons, therefore, must be the negative particle, so they have a charge of -1 because they are equal but opposite to the charge of a proton. You've then been asked to give the formula of the following ionic compounds, and you've also been given the formula ions, but do note you will be expected to learn these for the exam. So potassium oxide, we know potassium is group 1, so forms a +1 ion. Oxygen is in group 6, so forms a -2 ion. If we swap the numbers, we need 1 oxygen but 2 potassiums, hence why it's K2O. We know calcium is in group 2, so it forms a +2 ion. Sulfate is given below, and that's got a -2 charge. Well, we know they already cancel out. So we're not going to need to do the drop the charge and swap the charge method because they already cancel, so you only need 1 of each. So it'll be CaSO4 because you need 1 calcium and 1 sulfate. And then aluminium is group 3, so it forms a +3 ion. Nitrate is given below and forms a -1 ion. If we swap those charges, you're going to need 3 nitrates and 1 aluminium, so it's Al brackets NO3 close bracket 3, and we're using the brackets to show you need 3 lots of the overall nitrate ion. And if we move on to the last lesson question, it says, is the melting point of sodium chloride high or low? Well, we know sodium is a metal because it's on the left of the periodic table. Chlorine is a non-metal because it's on the right of the periodic table. So sodium chloride has ionic bonding, and we know the melting point of ionic compounds is high because lots of energy is needed to break the strong electrostatic forces of attraction between my oppositely charged ions, my positive sodium and my negative chloride ion. So this lesson, we're going to look at a different type of bonding that we haven't considered before, and that's our covalent bonding. And that's why it's really important in the exam you are really clear on that distinction between ionic bonding, covalent bonding, and then maybe look at another type of bonding in a couple of lessons, metallic bonding as well. So as a recap, pause the slides and have a go at the following questions. So looking at question 1, we know atoms of elements form bonds to get a full outer shell of electrons because that makes them more stable. There are 2 ways atoms can form bonds. The first way is by losing or gaining electrons, and that's how they form ions, and that's how ionic bonds form. but they could also share electrons instead, and that's what we're going to look at this lesson. You've been asked, what is an ion? Well, that's an atom with a charge, and they're formed either by gaining electrons and becoming negative, or losing electrons and becoming positive. And an ionic bond is the strong electrostatic force of attraction between oppositely charged ions. And to draw that dot and cross diagram for magnesium oxide, we know magnesium is group 2, so there are 2 electrons in the outer shell, so it loses 2 electrons to form a +2 ion, and we only need to show those outer shell of electrons. Oxygen is group 6, so it gains 2 electrons to form an ion with a -2 charge, and we've got magnesium trying to lose 2 electrons and oxygen trying to gain 2. So we know that oxygen will take 2 from the magnesium, and we've shown that using our crosses. And we do know it's a dot and cross diagram, so we've got dots to show the electrons of oxygen and crosses to show the electrons of magnesium. So far we've looked at ions forming by losing or gaining electrons, and we've looked at them forming electrostatic attractions with oppositely charged ions to form an ionic bond. What we haven't considered is the idea that the atoms could also share electrons with another atom in order to get a full outer shell and have that stable arrangement. And this is what gives rise to our covalent bonding. So you need to be really clear between the differences between an ionic bond and a covalent bond. So the definition of a covalent bond is it's a shared pair of electrons. So all you need to write for the definition is that a covalent bond is a shared pair of electrons. So for every covalent bond, 2 electrons are shared. One will come from one of the atoms and the other will come from the other atom. So that's my shared pair. So as you can see here, we've got those electrons overlapping, and this here is my covalent bond. Okay, that overlap of electrons, that shared pair, is your covalent bond. One has come from this hydrogen, and the other electron has come from that hydrogen. They are not losing electrons, nor are they gaining them. They are instead sharing them. So now, instead of both atoms only having 1 electron in that first shell, they now have access to 2 electrons. And if you think back to electron configuration, 2 electrons in the first shell means it's full. So this atom, or these atoms, are now stable. That's what a covalent bond is. They are formed by a shared pair of electrons. That means that they form from 2 non-metals. So your check in the exam is a metal and a non-metal would be ionic, but 2 non-metals would be covalent. So before you answer any question about structure and bonding, you need to decide what type of bonding is present in the compound. In this case, it will be covalent because we've got 2 non-metals. However, if you were asked to define it, it's this yellow box here. So you do not need to say it's between a metal and a non-metal or 2 non-metals. You need to say what it actually is holding those atoms or ions together. So here's our step-by-step method, which we'll always refer back to for doing a dot and cross diagram for covalent bonds. So as well as doing it for ionic, you also need to be able to draw out covalent bonds as well. And these questions are more common in the exam. So you need to write down the chemical formula. So for example, water is H2O. So you write down what atoms you need and how many of them. So I need, for water, 1 oxygen and 2 hydrogens. I draw the outer shell of those electrons and I figure out how many covalent bonds are going to be formed. For each covalent bond I figure out, I just do a dot and a cross and then I count to make sure all of the shells are full. But this will become clearer when I go through some examples. So let's start with chlorine. Chlorine has the chemical formula Cl2. Therefore, I need 2 lots of chlorine atoms. I know it's in group 7, so chlorine atoms have 7 electrons in the outer shell. 1, 2, 3, 4, 5, 6, 7. And it's a dot and cross diagram, so I'm using dots to show the electrons of one of the atoms and crosses to use to show the electrons of the other atom. so we can clearly see where each electron comes from. Now, if chlorine's in group 7, that means it needs one electron to get a full outer shell. And the rule is they will make however many bonds they need to get a full shell. So if chlorine needs one, they will make one covalent bond. Now, once you've figured that out, that means all you need to do is do a dot and a cross in the middle, and that's your covalent bond. So because chlorine only needs one electron to get a full outer shell, that means it will form one covalent bond. So you start by drawing your dot and your cross, and then do the rest of your shell. And if I count to check it's right, I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons for this chlorine, and 1, 2, 3, 4, 5, 6, 7, 8 electrons from that chlorine. They now both have full outer shells, so they are both stable. If you look at bromine, again, we only need to include the outer shell of electrons, just like for ionic dot and cross. Bromine's in group 7, so they both have 7 electrons in the outer shell. They need one electron to get a full outer shell, so each bromine atom will form one covalent bond. So I'm going to draw one dot and cross in the middle of those atoms. So this is my covalent bond. If I count, I've got 1, 2, 3, 4, 5, 6, 7, 8 electrons surrounding that bromine atom, and 1, 2, 3, 4, 5, 6, 7, 8 electrons surrounding this bromine atom. Both have access to 8 electrons in the outer shell, so they are both stable. So let's look at an example of water. So pause the slides and have a go at drawing a dot and cross diagram for water. First of all, we know the formula for water is H2O, so I'm going to need 2 hydrogen atoms and 1 oxygen atom. Hydrogen has 1 electron in the outer shell, so you're going to draw 2 hydrogen atoms each with 1 electron. Oxygen has 6 in the outer shell, so you're going to draw oxygen having 6 electrons. And the way you position it is we tend to draw the central atom, so the one that's only one of, in this case oxygen, in the middle. And we draw the other atoms around it. So each hydrogen needs 1 electron to get a full shell. Oxygen needs 2 electrons to get a full shell. So hydrogen can make 1 covalent bond. Oxygen can make 2 covalent bonds. So as soon as we've figured that out, we can draw our covalent bonds for oxygen, because each oxygen is going to make 2 covalent bonds. And each covalent bond is my shared pair of electron, so my dot and cross. So that means it's going to form a covalent bond with hydrogen here, and it'll form a covalent bond with hydrogen over here. So to see that properly drawn out, you can now see hydrogen has 2 electrons in its outer shell, so does this one. But oxygen now has access to 1, 2, 3, 4, 5, 6, 7, 8. So all of these atoms now have a full outer shell. So we're just following that method every time. For hydrogen chloride, I'm going to need 1 H and 1 Cl. Hydrogen has 1 electron in the outer shell. Chlorine has 7. So to draw the atoms, we just draw them like this, using dots for hydrogen, crosses for hydrogen, and dots for chlorine. Chlorine needs 1 electron to get a full outer shell. Therefore, chlorine will make 1 covalent bond. So I'm going to draw 1 dot and cross with hydrogen. So hydrogen now has access to 2, 1, 2. Chlorine has access to 1, 2, 3, 4, 5, 6, 7, 8. The trickier example comes from double covalent bonds, but we'll go through these in turn and then we'll apply our knowledge to try some of the trickier scenarios. So for example, carbon dioxide has the formula CO2. So I'm going to need 1 carbon and 2 oxygens. And when drawing this out, I'm going to make sure carbon is positioned in the centre because there's only 1 of them, and oxygen will surround it. Carbon is in group 4, so has 4 electrons in the outer shell. Oxygen is in group 6, so has 6 electrons in the outer shell. And I've used dots to show my electrons of oxygen and crosses to show my electrons of carbon. If carbon's in group 4, that means it needs 4 electrons to get a full outer shell. Therefore, carbon can make 4 covalent bonds. Oxygen, on the other hand, needs 2 electrons to get a full outer shell, so each oxygen can make 2 covalent bonds with carbon. So this time, what's going to happen is this oxygen will make 2 covalent bonds with carbon. This oxygen will make 2 covalent bonds with carbon, and carbon will make 4 covalent bonds in total, 2 here and 2 here. So to draw that, you're going to have 2 covalent bonds on the left, so a dot and a cross, and a dot and a cross, and 2 covalent bonds on the right, so a dot and a cross, and a dot and a cross. So below, it would look like this. You've got 2 bonds from oxygen here, there's 1. So here is 1 covalent bond, here is another. And you've got 2 bonds from oxygen on the right, there's 1 covalent bond, and there's the other. So now oxygen has got 1, 2, 3, 4, 5, 6, 7, 8 electrons in the outer shell, and this oxygen has the same, whereas carbon's got 1, 2, 3, 4, 1, 2, 3, 4. So that's how you would draw a dot and cross diagram when you've got double covalent bonds involved. This would also look like this in the exam, or you can, if you were asked to draw it as a stick diagram, so you'd have carbon in the middle, double bond to oxygen, and a double bond to oxygen on the other side. Each line is a 1 covalent bond, so each line is effectively a dot and a cross. So you'd have a dot and a cross here, a dot and a cross there, and 2 more there. Pause the slides and have a go at drawing dot and cross diagrams for the following compounds, starting with the green and working your way down to the red, more difficult examples. So if we look at fluorine, we know each fluorine atom is in group 7, so they've got 7 electrons in the outer shell. Each one needs 1 electron to get a full shell, so fluorine makes 1 covalent bond. So in the middle of those 2 atoms, I'm going to have a dot and a cross. Each fluorine has 7 electrons of their own and access to the 8th from that shared covalent bond. So they've now got 8 electrons in the outer shell. They are stable. HBr, hydrogen bromide, well, hydrogen has 1 electron. Bromide has, or the bromine has 7. So they both need 1 electron to get a full outer shell. So they're going to make 1 covalent bond. So I've got 1 dot and cross between those 2 atoms. Hydrogen has now 2, and bromine has access to 8. So they are both full and both have a stable arrangement of electrons in their outer shell. The more tricky example, so if you start with methane, CH4, carbon's going to go in the middle because that's my central atom because there's only 1 of it. Carbon's in group 4, so it's got 4 electrons, so 1, 2, 3, 4. Hydrogen's in group 1, so has 1 electron of its own, 1, 2, 3, 4, as shown by the crosses. Carbon can make 4 bonds, and hydrogen can make 1. So you're going to have 4 covalent bonds, so 4 lots of dot and crosses in the middle, but with 4 separate hydrogens, because even though carbon can make 4, hydrogen can only make 1. So you've got 1 covalent bond here, 1 here, another here, and 1 there. So carbon's now got access to 1, 2, 3, 4, 5, 6, 7, 8, and hydrogen has access to 2. So they're both satisfied. If you look at ammonia, NH3, I need 1 nitrogen that's going to go in the middle, and 3 hydrogens, and they're going to surround it. Nitrogen is in group 5, so there are 5 electrons in the outer shell. Hydrogen has 1 electron in the outer shell. Nitrogen needs 3 electrons to get a full shell, so nitrogen is going to make 3 covalent bonds. Each hydrogen is going to make 1 in return. So we've got nitrogen in the centre, and we've got 3 covalent bonds, so 3 dots and crosses overlapping each atom. So there's 1 covalent bond, there's 2, and there's the third. Nitrogen has now got access to 1, 2, 3, 4, 5, 6, 7, 8. And again, we've been really careful to show dots to represent the nitrogen electrons to see where they've come from, and crosses to represent the hydrogen electrons. The last two examples and the more trickier ones, so we've got oxygen. Each oxygen is in group 6, so they have 6 electrons in their outer shell, so they both need 2 electrons to gain a full outer shell. That means oxygen will form 2 covalent bonds each. So in the middle of the 2 oxygen atoms, you're going to have 2 covalent bonds, a double. So you're going to have a dot and a cross, and another dot and a cross. So you're showing 2 covalent bonds, one here and one there. So now oxygen's got 1, 2, 3, 4, 5, 6, 7, 8 electrons. If we move on to hydrazine, a trickier example, you've got 2 nitrogens, and each nitrogen is bonded to 2 hydrogens. So let's start by looking at our nitrogens. Each nitrogen has 5 electrons in the outer shell. That means hydrogen needs 3, so hydrogen will make 3 covalent bonds. One with hydrogen, another one with this hydrogen, and the third with this nitrogen. So for every nitrogen atom you draw, you're going to draw 3 covalent bonds, so 3 dot and crosses with the other atoms. So there's nitrogen, there's 1 dot and cross, so 1 covalent bond. There's another with the other hydrogen, and there's another with the nitrogen. And it's got 5 in total, so it's got 2 of its own left. 1, 2, 3, 4, 5, 6, 7, 8. So the nitrogen's happy. The other nitrogen has got a bond here, so we need a dot and a cross to that nitrogen. It's got a bond to hydrogen, so that's this one here, a dot and a cross to hydrogen, and a bond to that hydrogen, so a dot and a cross there. And again, it had 5 of its own, 1, 2, 3, 4, 5 crosses, and it's gained 3 in return, or shared 3, I should say. So it's got access to 1, 2, 3, 4, 5, 6, 7, 8. So that is how we draw dot and cross diagrams for covalent molecules. So there's plenty of practice to be done. You can think of your own and try and practice those, but there are more examples in your workbook to try and get familiar with dot and cross diagrams for covalent compounds.